Siphonophore. Not one animal, but a colony. At first glance, a siphonophore looks like a single drifting creature, something like a jellyfish stretched into a long glass chain. But that first impression is wrong. A siphonophore is a colony made of many specialized bodies joined together. One set of units helps capture prey, another helps with feeding, others deal with reproduction or movement. Alone, those parts could not survive for long. Together, they become one of the strangest predators in the ocean. Some siphonophores use long tentacles to sting and trap prey, injecting toxin to incapacitate it. And some species become enormous. In the twilight zone, certain gelatinous siphonophores can form chains up to about 130 feet long, making them some of the biggest animals on Earth by length. The deep begins with a body plan that already breaks the rules. Lanternfish. Tiny bodies, massive importance. Lanternfish do not look dramatic enough for the job they do. Most are small, dark, and easy to overlook. But they are among the most abundant mesopelagic fishes, and mesopelagic fishes as a group are among the most abundant vertebrates on Earth. Lanternfish carry light-producing organs called photophores, especially along the belly. Those lights help blur their silhouette against the faint glow from above, making them harder for predators below to spot. They are also part of one of the biggest daily migrations on the planet. Many spend the day deeper in darkness, then rise toward the surface at night to feed before sinking back down before sunrise. That makes them more than just another fish. They are a conveyor belt of energy, linking surface productivity to the deeper ocean. And they are eaten by an extraordinary range of predators. A lot of the deep ocean runs on small fish like these. Comb jelly. Soft, transparent, and still a predator. Comb jellies look too delicate to matter. They seem like pieces of drifting glass with almost no weight to them at all. But they are predators, and they move in a way almost no other large animal does. Instead of fins or muscles doing most of the work, they swim with 8 rows of fused cilia called combs. Those comb rows beat like tiny oars, pushing the animal through the water. When light hits the moving cilia, they create shimmering rainbow colors. That effect looks like bioluminescence, but it is not. It is light being scattered by motion. Comb jellies are also carnivores, often feeding on small arthropods and larvae, and deep-sea species are important as both predators and prey in midnight zone food webs. They look gentle, but they are built to hunt in a place where anything edible matters. The deep sea loves soft bodies, but soft does not mean passive. Gulper Eel. The gulper eel looks like a bad idea that somehow worked. Most of the body is thin, almost ribbon-like, and then suddenly it ends in a mouth that looks absurdly too large. That oversized jaw is the whole point. Food is scarce in the deep sea, so the gulper eel is built to swallow almost any morsel it comes across, big or small. Its mouth can expand dramatically, and its stomach can stretch to handle prey that would seem unreasonable for such a narrow fish. Scientists also think the glowing tip of its tail may act as a lure, drawing prey close enough for the strike. It is not a fast, elegant hunter in the surface ocean sense. It is a solution to a hard environment. In a world where the next meal might not arrive anytime soon, the safest strategy is simple. Make sure you do not miss it when it does. Anglerfish. At first glance, it looks almost unfinished. A dark body, a huge mouth, and a face built around one idea. Get close, then strike. What made anglerfish famous is the lure. A modified fin ray extends from the head like a fishing rod, ending in a glowing bulb that shines in the dark and draws prey toward the mouth. In the deep ocean, where food is rare and visibility is almost gone, that is an incredibly efficient trick. The fish does not need to chase much. It lets curiosity do the work. The mouth does the rest. Deep-sea anglerfish have long, inward-pointing teeth that help keep struggling prey from escaping once the jaws close. And in some species, the body plan gets even stranger. The female is much larger, while the male is tiny. He bites onto her body, fuses with her, and becomes permanently dependent on her for nutrients, while providing sperm when needed. So even by deep-sea standards, the anglerfish is unusual twice over. First, as a predator built around deception, and second, as an animal whose reproduction looks almost as strange as its hunting. Dumbo Octopus. The Dumbo octopus still looks like an octopus, but it has clearly been rewritten by depth. Its best-known feature is the pair of ear-like fins that give it its name. Those fins help it move through the water with a slower, more drifting style than the quick jetting motion people usually associate with octopuses. More revealing than the fins, though, is what it lacks. The Dumbo octopus does not have an ink sac. In permanent darkness, ink has little value, so that defense has been reduced out of the design. It is one of the deepest living octopus groups known and has been found around 4,000 meters deep. That alone tells you something important about the deep sea. It does not always invent entirely new body plans. Sometimes it takes a familiar one and strips away whatever no longer makes sense. Less waste, less theater. Just the parts that still work. Amphipod. Amphipods are easy to underestimate because most of them are small. They are crustaceans, related in a broad way to shrimp and other familiar forms. But in the trenches, they become one of the defining animals of the descent. Scientists working with baited landers in hadal depths have described a pattern that says a lot about trench life. As the landers descended, amphipods became more numerous, and just past the lower limit of snailfish, at around 8,000 meters, they exploded into dense pink clouds around the bait. Even at 10,000 meters, they were still among the most common animals passing the cameras. They will eat almost anything that reaches the seafloor. Researchers have found gut microbes in hadal amphipods that can digest wood, and bait often comes back stripped clean in hours. In the absence of other food, they will even turn on one another. Down here, recycling is not a side job, it is survival. Mariana Snailfish. The Mariana Snailfish is one of the clearest examples of what it takes for a vertebrate to survive in the hadal zone. In the Mariana system, trench snailfish were already known from roughly 6,198 to 8,145 meters, and the species Pseudoliparus swirei lives below 6,000 meters in the Mariana Trench. It does not look heavily armored or especially powerful. In fact, its body seems almost unfinished by shallow water standards. It has transparent, unpigmented skin and scales, thin and incompletely ossified bones, an inflated stomach, and a skull that is not fully closed. But those are not flaws. That is the design. At these pressures, rigid structures become harder to maintain, and the fish is adapted accordingly. It is one of the strongest reminders that depth does not always favor tougher-looking bodies. Sometimes it favors softer ones. And even then, there is a limit. The deepest confirmed fish ever filmed was a snailfish at 8,336 meters. After that, the trench continues, but fish probably do not. Sea cucumber. Sea cucumbers sound unremarkable until you look at what they actually do in the deep. Food is scarce, so many deep-sea sea cucumbers feed on nutrients attached to the sediment itself. They use their tube feet to take in seafloor mud, extract what little nutrition is left in it, and expel the rest. That is why they are sometimes called the vacuum cleaners of the sea. Their bodies also make sense for depth. They do not have lungs or gas-filled spaces that would become dangerous liabilities under intense pressure. Instead, water is pumped through internal respiratory trees. Some deep-sea forms even swim, but many simply work the bottom, processing the sediment grain by grain. In the Mariana Trench, sea cucumbers are especially important because they dominate some of the trench's biological communities. That means one of the most successful animals at extreme depth is not a hunter or a giant fish. It is a soft-bodied processor of mud. Deep-sea isopod. By the time you are deep in the Mariana Trench, one of the creatures you may meet looks like an oversized pill bug from another planet. NOAA documented an isopod more than 5,830 meters down in the trench, and that sight makes immediate sense once you know what deep-sea isopods are built for. As a group, giant isopods are armored scavengers, close relatives of the pill bugs and sow bugs found on land. They have large eyes, long antennae, a hard exoskeleton, and a body plan made for crawling, wading, and feeding on whatever dead material reaches the bottom. They can even curl up to protect their softer underside. In deep water, that kind of build is useful. You do not need speed all the time. You need patience, protection, and the ability to turn a rare food fall into survival. The trench floor is not ruled by one iconic monster. It is held together by animals like this, tough, opportunistic, and built to endure scarcity.